Okay, so here is a problem. Pretty simple truss. 3 elements. It's triangular, so we know we have good stability. And it wants to find all the forces in the truss. A couple different ways you can go about it. Let's just talk about it for a second. Is it possible to find all the reactions to this particular problem? Sure. There's 2 at A, 1 at C, so I can find my reactions at A and my reactions at C. Oh, one thing I should have said first. Do you see any zero force members? No. All the connections have 2 elements, but everyone also has applied forces, either in applied forces or reactions. So there's no case 1, which we called them, and there's no case 2 from the geometry. So again, as we mentioned before, there's probably going to be lots of ways to go through this, but I'm going to start by finding my reactions. So I'm going to come over here, and I'm going to quickly draw kind of a free body diagram of the structure. And I'm going to assume that I have reactions at A in the X and Y direction, and then 1 at C in the Y direction, and then I have this applied load over here at B, which is 60 kilonewtons. And you can see the dimensions. So looking at that, how can I find these reactions? Well, like our previous problems, we like to sum moments at pins because there's 2 forces there. So we'll do the same thing here. So I'll sum moments using right-hand rule for my sign convention, and I'll start at A. So I want to make sure that about A, that all the equilibrium of the moments for these forces are balanced. So using right-hand rule, my reaction CY is going to create what kind of moment about A? Positive or negative? Positive. So I'll have CY times this distance, which I forgot to write, it's 5 meters. And then I'll have the 60 kilonewton force over here at B, and it's going to create what kind of moment? Negative moment. So it'll be 60 kilonewtons, and that moment arm is this distance, which is 5 meters, and then another 5 meters. It's 10 meters. Sorry, I just kind of ran out of space there. Forgive myself. That actually is 10 meters. That may not look like it. So when you solve for CY, what do you get? 120. Now I can sum forces in the Y direction. Since I have CY, I should be able to solve for AY. So I'm going to assume up is positive, so I have AY up, CY up, and 60 down. So AY plus CY minus 60 kilonewtons. So when you solve for AY, what do you get? 60 kilonewtons, right? But it's negative. Does that make sense? Does it make sense that AY needs to be pulling down? Well, if you look at this is kind of like a really crazy seesaw. I'm pulling down here 60, pivoting about C. I better pull down here at A equal to kind of balance it. So I like that. And then the last part, to finish off my reactions, is I'll sum forces in the X direction. And for this problem, the only X component I have is AX. So AX is 0. So I know everything at A, externally in C, so I'm ready to go. Now of the joints I have, A, B, and C, is there any one I cannot go to and write 2 equations and 2 unknowns? No. They're all good. Is there ones that are better than others? Yes. I think A is okay, And in the standard XY system, you'll only have one element with a Y component, so that's good. Same thing is true here at C. If you go to B, the problem is both forces have X and Y components. You can solve for them, but you would probably have to do it simultaneously. And I know you guys don't like to do that. I don't like to do it. If you rotate the axis locally, you can do that too, but then the geometry might get a little messy. So I think we can get the problem done by just doing A and C. So that's going to be my strategy. So if I come over here and draw a free body diagram for joint A, this is what I get. There's my free body diagram. Pretty cool, huh? See it? It's right there. Now what are the forces on that? Well, what's AY? I assumed it was up and it's 60, but it's actually down. So I'm going to apply that as a force of 60 kilonewtons. What's AX? 0. And now I'm going to assume tension forces in all my elements. So I'll have AC in tension, and I'll have the force in AB in tension. I can write two equations of the joint. I have two unknowns. What's this rise over run here, just so I can get my geometry? It looks like that element goes 10 to 5, right? So that's really 2 to 1. So what would the hypotenuse be? Square root of 5. You guys see that? So I'm going to use that when I break my components down. Should I sum forces in the X or Y first? Which one should I do first? Y. Yeah, Y. If I do X, I'm going to have both forces, so I'll have one equation and two unknowns. Not a good place to start. So if I do Y first, I should get one equation and a single unknown. So let's do that. I'll sum forces in the Y direction. Make sure it's in equilibrium. I'm assuming up is positive. So my force in AB is positive, and what would be its component? Well, it'd be the vertical part, which is 1 over the square root of 5. You guys see that? If you feel more comfortable computing the angle and then taking the sine or cosine, please do that. I like doing this better. Just me. And it's acting up, and then I have my 60 kilonewton force acting down. So I should be able to solve for the force in AB. What is it? It's whatever 60 times the square root of 5 is. 135, I'm guessing. 134.2? And I got a positive number, so what does that mean about AB? It's in tension. Does it make sense that AB is in tension? Yes. I think so. Now that I have AB, I can sum forces in the X direction and get what? AC. So let's do that. So I've got AC to the right, that's positive. And I've got the X component of AB, which is 2 over the square root of 5. And when you solve for AC, I think you're going to get 120. And it should be negative. I'm guessing. Is that right? Does it make sense that AC is in compression? Well, think about that. When you pull this down, what do you think is going to happen to BC? It's going to get shorter or longer? Shorter. And as it gets shorter, is C going to move to the left or to the right? It's going to move to the left. So as it moves to the left, that means AC should get shorter. Compression. So you should be able to kind of get a sense for that. Now, I can sense by your movements that we're out of time. So I'll stop here. But what I'll do is I'll finish this up by going to C and finding the last piece, and I'll post that solution online. Okay?
You're teaching statics.
Statics.